One of the most important things in redox reaction is to figure out the oxidation number or oxidation states. Now, what are oxidation numbers and states? Well, in our previous video, we talked about how redox are in terms of the loss or gain of electrons and oxygen. But now, and then I gave, towards the end of the second video, I gave an example about how some reactions are that are not made of ionic compounds, and it'll be kind of hard to determine whether it is an oxidation, which element goes through oxidation and which other element goes through reduction in the redox process. And so chemists have invented this imaginary numbering system called assigning oxidation numbers to assume that if the covalently bonded molecule or even ionic compounds, what happens if we were to treat all molecules in compounds as ionic compounds, and who will actually take the electrons or possess the electrons, and which other elements will be losers and not have electrons with them, because electrons is the currency of chemistry. Alright, so here we go. We need to know the rules to assign oxidation numbers. And here we go. Here's the rule. Let me briefly explain, and you should pause the video and copy this table down. Good. Let's hope that you copy the table down. So here we have elements in this column, the oxidation numbers that are usually assigned to each of these elements, and the exceptions. Alright. Group 1 and Group 2. Very easy. If there are metals in Group 1 and Group 2, you give them an oxidation number of 1 and 2. Oxygen usually has a negative charge of -2, has an oxidation number of -2, except when it's bonded to a peroxide or fluorine. Hydrogen always has a oxidation number of +1, except when it's a metal hydride. In that case, it will have an oxidation number of -1. Fluorine, the most electronegative element in the periodic table, always has a -1 charge, oxidation number of -1. Chlorine will usually have an oxidation number of -1, except when it's bounded to another molecule, another element like oxygen or fluorine. Elements, metal elements by itself, have an oxidation number of 0 because the electrons are shared equally or on its own. Diatomic elements will have an oxidation number of 0 because the electrons are shared equally among the two atoms. Okay, so here we go. Now that you've got the brief rules, these are kind of rules you have to memorize. Exceptions are not really popular in IGCSE, but that is okay. It's good to know it now. Alright, examples. And now we're going to talk about how to assign oxidation numbers for all these examples. And I'm going to go through it one by one. Alright. And nitrogen gas is a diatomic molecule. And because it's diatomic, it has N and N, it has an oxidation number of 0. And the reason why is that you have two ends that are triple bonded, and they basically share equal amounts of, share their electrons equally. So there is no real giving or taking of electrons in this end. Alright? Iron metal. It's an element, so it has oxidation number of 0. Oxygen, another diatomic molecule, has an oxidation number of 0. Now, we're going to start with some ionic compounds. We know that NaCl. When we assign them oxidation numbers, we have to go down the rules that is listed on the table. Na is group 1, so it must have an oxidation number of +1. While chlorine, on the other hand, has to have an oxidation number of -1. Alright? when you sum up these numbers, it will be 0. Alright, magnesium chloride is in group 2. Magnesium is in group 2, so we can assign them a number of oxidation number of +2. For chlorine, it will be -1. But remember, there's 2 chlorines here, so it too will sum up to 0 when you have +2 and 2 times -1, which gives us -2, and we have a sum of 0. Okay? Now, it is important that the sum of the oxidation numbers at the top to equal 0. Why? Because when we get to the case where it's a covalent molecule, then we're going to now have to kind of pretend that it is ionically bonded, even though it's not. All right? Remember, redox is just simply a mechanism for chemists and scientists to understand the process of what the electrons are doing during the chemical reaction. Okay. So carbon. Well, carbon is not in the list, but hydrogen is. So let's give that a +1. So what could the charge for carbon be? Well, +1 multiplied by 4, because there's 4 hydrogens, will give us +4. So that means the oxidation number for carbon must be -4. Easy, because when you sum that up, it will also equal 0. Lithium hydride. Now that's a metal hydride. Well, metals we know has lithium is group 1, so it must have a +1, and hydride, because this is a hydride, it must be a -1. Okay? H2O. Now it's a covalent molecule, but we're going to assume that it's ionically bonded for the purpose of assigning oxidation numbers. So let's do it. Here, oxygen is always -2, right? Except when it's peroxide, so it's -2. And hydrogen is +1. Very easy. You sum up these numbers, it will be 0. All right? +1 times 2, sum up with -2. All right. All right. Difluorine oxide. Okay? Here, it's an exception because now oxygen is bonded to fluorine. So we can't really use the rules on here because that's an exception. But we know that fluorine is always -1 for this oxidation number because it's the most electronegative element. So we give that a -1. And there's 2 of it, so what must the charge for oxygen be? +2. Whoa, kind of cool, right? Okay. HCl, very popular chemical. This must be a +1, and this must be a -1 for its oxidation number. Now we get into the juicy one. These are polyatomic molecules, all right? So what is this? That's sulfuric acid. What could the oxidation number be? Well, we know that hydrogen is a +1, oxygen is a -2. So if you sum this up, you will get a +2. You sum this up, you get a -8. All right? When you take the difference between +2 and -8, that should be +6. And since sulfur is the only one that has no oxidation number, you're going to assign it an oxidation number of +6. All right? Now, you may need to rewind the video to show what I just did and do it in slow-mo. All right? Copper sulfate, another very popular molecule. Well, what's the oxidation number for copper? We don't know because, again, it's a transition metal. But we can look at it as this whole thing being -2, and so this must have an oxidation number of +2. Here, each oxygen has an oxidation number of -2. And so when you do the arithmetic, you will also conclude that sulfur has an oxidation state of +6. Now, the last one. Chloric acid. What's the oxidation state of hydrogen? It's a is a +1. Oxygen has to be a -2. There's 3 oxygens, so that gives us a -6. And there's 1 on here. So what should the oxidation number for chlorine be here? Well, you sum up the difference and you will get -5. So chlorine must neutralize this -5. So the oxidation number for chlorine must be +5. So that is the rules for oxidation number. Brilliant. Now we can go further and now use this knowledge here to kind of predict which element is reducing and which element is oxidized, which element is reduced and which element is oxidized when you have all kinds of chemical equations. And we'll do that next time.